Hello, this is a small review of the surface mount assembly surface offered by JLCPCB. The service was started maybe about 2 months ago and I was very eager to try it. So in this video I would describe what my experience with the service was and some lessons learned. First things first, this is the small project that I used to test the service. Obviously I wanted something small in case things go wrong, so it is an affordable endeavor. This is 10 piece, so you can see 10 boards. I ordered a very small design, which is a DC step-down converter from a 12 to 24 volt input to 5 volt output. Nothing too complicated about it. And the boards arrived held together by this sticky tape. The boards are separated from each other, you can see, and they're just glued to this here tape. There was bubble wrap. Other than that, nothing fancy. I would go over the steps that I took to produce these boards. And what are some caveats with the service that I learned, etc., etc. So let me show you what the project looks like in KiCAD. I would assume that you have some basic knowledge of how to design electronics with KiCAD. If not, there is a lot of online tutorials you can look into. I will not go into details, and I would assume you know how to design electronics and make PCBs already. So the project that I was going to try is this very simple schematic right here. Nothing to the schematic. This is a simple buck converter chip. The schematic is straight from the manufacturer data sheet. It's entered into KiCAD already. The only thing you need to do is that is different than what you would normally do is in each component you need to enter the manufacturer part number and the JLC part number from their parts library, because they would only allow you to use components that are in their parts library. I found their parts library to be very extensive, and that was not a limiting factor for me so far. And here is how you enter this additional information. So for each component on the schematic, you select it, and then you hit the E key on the keyboard to edit the properties. And in here, you add 2 extra pieces of metadata, and one piece I name LCSC part and then the hashtag for a number. And then the other one I just named part number, which is the manufacturer part number. And the way you get 2 of these values, I will show you in a second. So let's say in the schematic I have this 10 microfarad 50 volt capacitor that I'm going to use, and I know from my PCB that this capacitor is a surface mount size 1206. So you would go into the JLCPCB website. In the SMT assembly section, you say, what is this? And here is a link to their parts library. The search in their parts library is not parametric, which is unfortunate, but you can pretty much type what you need and it will find the component for you. So in this case, I will type 10 microfarads 50 volt 1206 size, and lo and behold, it found 2 parts. The first part is what they call a basic part, the second one is an extended part. Always prefer the basic parts because they're usually cheaper and it costs less for them to install them on the board. So let's see if this would meet our needs. Well, looks pretty decent. There's a link to the data sheet if you have special requirements. But here are the 2 values that I mentioned in my earlier. So this is the LCSC part number is this value over here. Let me find it in the eScheme. The C13585. Sorry, here it is. C13585, and the manufacturer part number, you don't technically need it, I just put it in there as another piece of metadata, just for my reference. And the way you add these pieces, you click this here plus button. Let's say I can add another one. I can say AAA, and I would go here and I would say, well, the manufacturer is this. And I would call it manufacturer. And it is a little bit of labor intensive. I mean, you need for each part to go and search for the corresponding component and find the one you need. But after you're done, you save the design and then you have it. So it pays off at the end. So I have done this already for all the parts. You can see all the parts have the LCSC part number and the manufacturer part number. I have selected them from the website. And after you have done this and you have designed your PCB, here is the PCB I'm going to use for today. I have to make it slightly bigger because they have a minimum size of 20 by 20 millimeters, so I just made it bigger. The first thing you do is you go and you export your Gerber files. And I would assume that you already know how to do that. If not, again, there are plenty of tutorials. From the options, I prefer the Protel file name extensions and nothing else. You just hit the plot button and then you generate drill files. Again, Excel file format, absolute positions, and then just generate them. So this is pretty much what you would do to order any PCB from any manufacturer. So this is so far standard things. The other thing you need to do is from the file menu, fabrication output, export a footprint position file and then choose the CSV format. And this will generate a file which will tell the manufacturer the position of each component of your board. And then we will need to edit it, but we'll get that in a second. The other file that we would need, that is an extra for this step, is what is it called, a bill of material file. The way you generate it is you first need to install a special tool, which I will show just in a second. So the special tool you would need is a BOM export script that JLC has designed for KiCAD. The way to find the tool is you would go on their support section of the website, and you would click the SMT Assembly Support Questions. And there is a section which says how to generate the BOM and Centroid file from KiCAD. We already generated this Centroid file. I mean, there is instructions how to modify it in here, but I will tell you in the video. But the BOM file, there is a special script that is needed. Of course, they tell you how to do it step by step. The short version is, this is the instructions how to find these part numbers and other stuff. The short version is you click this Arturo's BOM export script link, which would send you to a website called GitHub. And in GitHub, you click this row button so we can see the text of the script only without any of the Chrome. And this is what it looks like. And then you right click on your browser and you just say, I want to save this thing as, and you just pick a folder where to put the script. I would just put it in my documents folder because I'm lazy, but you can choose any folder on your computer. And here it is. I would save the script. I already have it, but I will replace it with this new version. And let me hide this so it doesn't work. And then what you would do in eSchema, you would go in the Tools menu and you would go to the Generate BOM. And BOM or BOM is Bill of Materials. This is a file which tells the manufacturer what components you're using in your design. And this is a one-time step. We need to install this script that we just downloaded. We need to install it once. Once you install it, it's there for you to use. You can use it in as many designs as you want. And here is how you install it. From the Tools menu, you go to Generate BOM. And this is a list of scripts that are already installed. The script that we downloaded is not here. So the way to add it, you click the plus button. And now a dialog pops up to say, okay, where is the script that you want to add? And if you remember, I put my script in my documents folder. And the script is called BOM2 something something JLCPCB.xsl. You just select the file and click open. And the KiCAD is just asking for a name for the script. I just use the default, whatever this BOM something JLCPCB is descriptive enough for me. And you click OK. Now the other thing you need to change in here when it says command line running the generator, after the %O, you need to click with your cursor and add the magic symbol .csv. And this is so it would save the file as a CSV extension. By default, it saves it with no extension, which makes the file very, very hard to find. And now you can click the Generate button so we can generate our bill of material files. Here it is. Click. It says generation successful. And we close this dialog. Now, what do we need to do with these files? Pretty much the Gerber files that we just generated. I will show you there in a folder. I generate them in a separate folder than the project. Here is the project file that I use. These are the KiCAD files, and I generate all Gerbers in a subfolder called Gerber. And these are the Gerber files I just generated. Now, one thing that is special for JLCPCB is that KiCAD generates the outline of the board in a file which has the .gm1 extension. And JLCPCB wants this file to have .jko extension. Now, I already did that previously, so I have a file which has .jko, and I will just delete it. So this is what you would have the first time. When you do it more than once, you would have to delete the file just as I did. So you would go to this .gm file, select it, hit F2 to rename the file, and just change the extension to GKO. And it will say yes to confirm. And that is that. Now we need to package all these Gerber files into a zip archive, which I already have, and I would delete so I can properly demo the procedure for you. So these are all these Gerber files that we just generated. There is the MP power -bottom -post CSV and -top -post.csv. So these are the position files. We don't strictly need them, but if they're in the archive, they don't hurt. So because I just selected a bunch of files, I'm not going to deselect this file. And I usually right click on these files and use some sort of file compressor to make this into a zip file. I have 7-zip installed on my machine, so I would say add to archive. And I'm going to say that it's a zip archive, and I would name it DC Buck project.revision2. You can use whatever name you want, the name is not important. And here it is, I have a zip file with all my Gerbers. In addition to this zip file, I would need this top CSV file. Here it is, this is what was generated from the KiCAD software, and I would also need a file which is not in this folder, it's in the project folder, which is this bill of materials CSV file, which is mp-power-csv. And there is one more change which I would tell you in a minute, and then we will be ready to upload all of this to the manufacturer's website. So here is the last change that you have to do to these generated files. The position file that we generated from KiCAD has the wrong header, and in the JLC support documents they're describing the procedure that you have to change the header from these values to these values, and we will do just that. I would go back to my folder with the Gerber files. The file that I want is the name of my project -top-pos, which is the components that are on the top of the board. And you can just edit this file with a notepad or any other text editor. And you can see the first line says is just a header for the CSV file. And if we come here on the support website again, okay, I apologize, there is the file that I wanted to remove. So we have ref, which we need to change to designator. Val and package stay the same, then POSX needs to become midX, MID and then X. POSY needs to become MIDY, and then rot needs to become rotation, and then side, the last value from this header, needs to become layer. And that is that. So now we are ready to upload our files to the manufacturer. I will keep this file open because there will be one more change that we will need to do, but you will see that is an error in the file that we need to correct. So how do you upload all these things and order your assembled PCBs? Well, you go to the JLCPCB website and you say order now. And the first thing you do is you upload your zip file with all the Gerbers that define the PCB. And you click add your Gerber file, and then you navigate to the zip file that we created a little bit ago. Here it is. It's going to be uploaded just in a second. And then the system will process the file and will give you the images of the top and the bottom of the board. I don't have any silk screen on the bottom, so it will be added automatically. You don't change anything else by default. You can see I want a 2-layer board, 21 by 21 millimeters. Let's say I want 5 boards for now. We will be able to change the quantity later. It's important that you choose green mask, otherwise they won't let you do the assembly. You can choose a hassle, a LED, or a LED-free hot air soldier leveling. As a surface finish, I just choose the default because I am lazy. And now the interesting part that they added while this whole tutorial is you flip this switch which says I want my PCB to be assembled. And the system asks you, do you want to put components on the top or on the bottom side of the board? They can do only one side for now. And we say our components are on the top side of the board. I have no components on the bottom. The other option that you want to choose is this tooling holes option. Again, on the support side, they explain what tooling holes are, and if you want to put them in a specific location of your board, you can. By default, I didn't do anything. This option wasn't available, and the manufacturer put the holes on my board when I ordered it. They did their best guess where they should be, but if you have any particular constraints, I mean, just put the holes yourself. I would just choose that they add the holes for me because this design is not sensitive and there's plenty of extra space for them to add holes. And I would say added by JLCPCB, which means they would add the tooling holes, and I would click confirm. And now the system asks me for these 2 extra files that we generated earlier. First, we're adding the bill of material files, and this is not in the Gerber, this is in the project folder. It's this CSV file that we generated with the script from the eSchema. And then I need to add the position file. This one is in the Gerber file folder, and this is the one which has top-pos.csv, the one that we changed the header on just 2 minutes ago. And I will select it and I will click open, and then we click next. And this is a very important step because you will discover an error in a little bit. First, the system loads all the parts that we have used in our bill of materials, and it locates them in the parts library. So I have all my parts already in the parts library, so I have pretty much match for everything. You would see that there are 2 types of parts. There is an extended part and a basic part. You can see the price for each part. And you should know that for each extended part, you will be charged $3 extra. So use basic parts whenever possible. I click next because all the values here are fine. And this is the really important step. Now we need to verify that our PCB, the components are positioned correctly. And most of the time they are positioned correctly, except for the rotation of some components. You can notice that my chip is rotated 90 degrees in the wrong direction. Actually, here is what they believe pin number 1 should be, and it should be here on the schematic. So we would need to go and edit the file by hand. I actually have a script to do this automatically, which I would share with you if you know how to run awk. But for now, I will just show you how to edit this file automatically and correct mistakes like this. So always double check where your components that have sensitive pins, like pin number 1, or like a diode that has an anode and cathode that cannot be flipped the other way. Always double check on the board that they're rotated in the proper orientation, because there is a difference between what KiCAD believes the chip orientation should be and what JLC believes the chip orientation should be. And if you made a mistake, you just have a bunch of useless boards. So to fix the mistake, we need to rotate this chip clockwise, which is -90 degrees. And the chip is called U1. So I would go back to this position file, the one that we changed the header of, and I will locate U1, here it is, and you would notice that rotation is the next to last value, which is here. It says -90 degrees. So we would need to add another -90 degrees, so it will become total of -180 degrees. And if you know something about rotations, you would know that -180 and 180 is exactly the same angle, so I would just put it 180. And I would save this file. Now I need to go back to their website and go back because I don't like the current setup. There is a mistake, and here is how to correct it. You go back and then you go back one more time to where we uploaded these two files, and I will upload the new file with the changes I just made. And here it is. Open. Ta-da! And then you click next and you wait for the thing to load and you click next one more time. And now we verify that our pin on the chip is where it's supposed to be. If you're not sure where the pin is supposed to be, you can consult your PCB and you can say, where is pin number 1? It is right here on the PCB. This is the KiCAD PCB editor. Here it is. And here it is, on the website. It is right here in the right spot. So this is so far correct. Now look at the pricing that we got for this board. So we got a special order, special offer for our PCB production. So they use just $2 for all our 5 PCBs. There is a setup fee of $7 for any assembled board. And then our components for all 5 boards that we ordered, you can see the prices here. 5 times 1 resistor, blah, 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 blah. The most expensive part is the chips, is the integrated circuit on the board. For all 5, it costs $2.64. And the other thing is the inductor that we use for the board. For 5 boards, it costs $1.22. All components for all 5 boards, a total of $6. We were also charged $6 for the 2 extended parts that we use from the library. Here it is. Extended part 1 is 1 resistor with a very specific value that we used. And the inductor was also an extended part. So each of these costs $3. So these are the $6, and then the grand total of all this thing is $21.04. So this is for 5 boards. Now, it does so happen that today they're offering us $7 off because it's Thanksgiving. I don't know if this will survive. This offer will survive by the time you watch the video, but we have a special today. That we can take advantage of. I will not take advantage of that, just so you can see how the price of this changes when you order more boards or less boards. Let me save this to my cart. And then I have another board that I have ordered previously, so don't get confused by the huge values. This is the one that we are experimenting with, this little DC converter board. And you can see the placing file as well if you hover with your mouse. Let's say I say, well, you know, I don't want to pay $20 for 5 boards. I want to have 10 boards at least. So you hit this edit button with the pencil once the thing is in your cart, and you can say, you know what, I want 10 of these. And it's gonna take him a while, but you can see that the pricing updated for 10 boards. The only thing that changed is the price of components. The setup fee remains the same. The extended component fee remains the same. Also, the price of my board changed because $2 was the special offer for up to 5 boards. When I ordered 10 boards, the PCBs themselves cost $5. So my total updated to $26. So I paid $5 more for 10 boards, which is a pretty good deal. And you can say, you know what, I want 20 boards. And it's going to do and recalculate the prices. Again, you get a little bit, actually the boards now are cheaper for some reason, so go figure. The component price increased accordingly because we're using more components. The extended component fee and the setup fee remains the same. So for 20 boards, the price is $33. So as you can see, you can play with this until you find something that is comfortable. Eventually, you can hit order and select the appropriate shipping that you want. And I will show you in a moment how long did it took for my boards to arrive, and we will inspect the board that I received so you can, feel confident about what you're about to receive. So here is an order I placed, so we can see how long it took. In my order history, so this is this same DC converter. This is a previous design with a much bigger inductor that you will see. The new board that I was trying to upload has a smaller inductor. But I placed this board on November 26th. I placed the order, and it was delivered on December 9th at 3 something p.m. And by the way, this wasn't the express shipping options. They have 3 options for shipping. There is DHL, which is the fastest and of course the most expensive. There is SF Express, which I prefer, which is somewhat cheaper than DHL and almost as fast. And there is a post link or something like that, and that is usually very, very slow. And when I say very slow, DHL usually delivers from China to my house in the US in Southern California in about 3 days. This SF Express, it usually takes them a week, and the third cheapest option usually takes 2.5 weeks. So that's the difference in the shipping speed. It will, no matter which shipping speed you choose, it will take you exactly the same time to manufacture the product. So this is how long it took to manufacture the board. So I ordered it on the 26th and it was done by the 29th of November. And then it entered the assembly line on the 26 something, and it was done on the 29th. Oh, they conflated the two things. Let me see. So the V scoring was done. I am sorry, this thing keeps popping up. Sorry, the PCB manufacturing was done on the 29th at midnight somewhere, 20 minutes past midnight. You will notice that from the assembly line, they did the first 2 steps in parallel, and the rest of the steps were performed after the PCB was manufactured. So this is at 3 in the morning on November 29. They started the solder paste printing, and then they placed the components, they reflowed the solder, they finished the assembly, and final inspection was done by 11 in the morning that same day. Apparently the factory works 24/7, which is really, really impressive. So my board total was done in 3 days, and the rest was shipping. Like, as I said, shipping took from the 30th, which is the next day, until December 9th. So that's about 9-10 days shipping. And I would now switch to my microscope so you can examine the board in more detail and can see actually the quality of the finished product. So this is a very cheap microscope, don't judge me, but it will give you an idea of the quality of the soldered components, if I can get it to work. There it is, now it's working. Here is the board, and you can see the grooves from the cutting. These are the soldered resistors. This one is just a little crooked, but nothing that is terrible. Then you can see the chip pins are spot on. This is the chip I'm using, this MP1584. And then these are the components which are slightly bigger. This is the input filter capacitor. This is the Schottky diode and the output capacitors. This little capacitor here is 0805 size. And you can actually see the little tool holes that they put on my board. So they would put two tooling holes like these on your board, and they will try to use an area which looks safe. And in this case, they did pretty good job. So here is the second tooling hole on the other side of the board. So they are diagonally placed, one on the top left and the other one on the bottom right corner of the board. And you have an option of putting these holes yourself if you want to choose the placement, if you don't trust them. From this experience that I had, I didn't know about the tooling holes, so they placed them, and it looks pretty decent. But if you want to control the placement, they have a tutorial on their website how to do that. And this is pretty much the longest video I have produced so far. I hope it was informative. And if you have any questions about this ordering experience for the assembly service from JLCPCB, let me know in the comments. Full disclaimer, I was not paid to do this video. I ordered the board, paid for it myself, and this is just a public service for people to know what it looks like to order a board and get it assembled from this particular manufacturer. Thank you for watching.